This is the changing economics of knowledge production. I'm Laura Veldkamp, and this is joint work with Simona Addis. The claim we often hear made is that big data technologies are like the industrialization of knowledge production. We want to ask, is this claim accurate? So we're going to measure it like industrialization. We're going to measure knowledge production with big data technology and see if this claim is true. So what does that mean to be like industrialization? Well, a key feature of industrialization is that it changed the relative intensity of labor and capital. So we're going to ask the analogous question for knowledge production: how much is AI changing the labor intensity of knowledge production? So the labor intensity and the data intensity. This matters for employment, it matters for labor income share, how much workers are earning, for the optimal firm size, competition, and for valuing data. Now, in order to investigate this claim, we're going to use data on the investment management industry because it's a knowledge industry and because they're early adopters of AI and big data technologies. The way we're thinking about this process is that firms start with raw or unstructured data, but that by itself is not very valuable for analysis. It needs to be processed, which means cleaned, structured, and warehoused. That structured data can then be used by analysts using either an old technology or a new big data or AI technology to create knowledge. The way we model this is using standard economic production functions. So knowledge is produced using either the old technology or the big data technology. We're going to call that AI for short. That's really not meaning artificial intelligence specifically, but it refers to a suite of new technologies that are data intensive. And we use the same data for both. So technologies, the key is that they have different rates of diminishing returns on data and labor. And so the question we want to ask using these standard production functions is alpha, that exponent above the data term, above the D, is that a lot bigger than gamma? Because if so, what it means is that as we accumulate more and more data, the marginal value of an additional increment of data is higher for the AI technology, and that's what's going to be analogous to industrialization. Now, key is that data inputs need to be structured, cleaned, and machine readable. And this is important because it requires labor, and we have data on that labor. So we're going to look at hiring of data managers, and that's our Lambda term, to infer how much data firms are accumulating. Another key assumption is that we're going to look at firms that optimize, which means they're going to set wages equal to their marginal product of labor, which means we can use wage as an additional piece of evidence to infer how much data they have and what the production function parameters will be. And so the goal is to use three types of labor: AI skilled, old technology skilled, and data management skilled, and their wages to estimate the exponents alpha and gamma.
So as Lara was mentioning, we're going to be bringing this model to the data in order to estimate these differences in parameters. How we do that is that we look at job postings data from Burning Glass Technologies from 2010 till 2018. In particular, we isolate all jobs that are demanded by investment management firms. And among those jobs, we identify the ones that belong to the three categories of interest: AI and all tech analysis jobs, or those data management jobs. We do this by identifying those skills that are most characteristic of these three types of workers and looking in the full text of each job posting, what is the relative frequency of these skills. That allows us to assign all of these jobs to the three categories, and that gives us an estimate of what is the demand for labor of each type for every single firm of interest in our time period of interest. Now, the model, though, doesn't require demand for labor, it requires stock of labor, or else how many workers are employed in each of those three categories of interest by each firm in each point of time. So we transform this demand for labor into stock of labor by using data from the Bureau of Labor Statistics. In particular, we adjust this labor demand by the industry and job type specific posting to filling vacancies rate, and also by the separations rate. Once we do that, we utilize data from 2010 to 2014 to cumulate up these variables. And then we use data from 2015 till 2018 to estimate the model parameters. What that means is, given the revealed preferences of firms in their hiring behavior and in their wages, What are those alpha and gamma that make most sense, that justify what we are observing in the data? In doing that estimation, what we find is that indeed alpha is greater than gamma. What that means is data has less diminishing returns when using the new technology. We estimate this model in 3 different ways using different assumptions by how fast data depreciates. Our baseline results are going to consider a 2.5% depreciation monthly, but everything still holds even if you assume a 10% depreciation, which means that after 10 months, data has no value. So what we find with this is that indeed, with the new technology, we're becoming more productive at analyzing data. So the value of each additional data point or amount of data that we can add more productivity, can add more output. And we can do that with a smaller proportion of labor to data. So we can use more data and less labor to produce the same amount of knowledge that would have required more labor before. So we find that indeed the labor share fell by 17% with the AI technology with respect to the old technology. To put this into context, similar work that has looked at how these parameters changed in the Industrial Revolution, they found in changing that exponent to data, which there would have been capital, of 0.12. We find a change of 0.17. So at least with our baseline results, this is quite comparable and it looks like it is a big change. Now, another question that people have in mind when thinking about this is, well, are machines gonna be stealing our jobs? So we go back to the data and we look at what are those trends looking like? What our model allows to look is how much data does each firm have and how is that changing over time? So on this right graph, you see the cumulative amount of data in this industry through 2015 to 2018. And here you see that the amount of workers demanded is also increasing. So what this is saying is the pie is becoming bigger. Yes, the labor is getting a smaller proportion, but we have so much more data that we're also hiring more to analyze this data.
So our last result is showing how our methodology can value data. So remember, the wage is the marginal product of labor, which allows us to say something about how much firms value it. And what we find is that the cumulative value of data has risen enormously. It's risen by 26% in 4 years. Now that's a combination of there being more data, but also because the marginal value of data is going up with these new technologies. So our takeaways are, we can infer how much data each firm has from looking at this data management hiring. That's their footprint for data accumulation in the labor market. We infer how much diminishing returns there is to data, both for the old technology and new technology, to ask which exponent makes hiring patterns closest to optimal. And we find the change in diminishing returns is large, which means we should see big shifts in firm competition, firm size. Thank you.
Hello, everybody. My name is Robert Farrukhnia. I have the privilege of teaching at Columbia Business and Engineering Schools. I'm also the founding executive director of Advanced Projects and Applied Research in FinTech at Columbia. I'm here with my colleague and co-author, Dr. Leon Perlman, presenting our research, which has been made possible by a grant through the Columbia-IBM Center. In our research, we are taking a broad and deep look into the regulatory framework affecting the world of blockchain and digital tokens and cryptocurrencies with the aim of demystifying, not only demystifying them all, but also providing frameworks for new thinking around this realm. Now, our aim today is to give you a high-level primer of our research and tell you what we have been up to. So in essence, the challenge we are facing in this world is this dichotomy that exists between the innovators and the regulators. The fact that innovators want to run really fast with their innovations and the regulators need to be able to understand it and protect the retail investors and even more. So both Leon and I are a believer in the role of responsible regulation and the fact that it can actually empower innovation. So our research aims to understand this dichotomy and be able to provide implementable solutions, especially given the fact there are a number of constituents in this space, which is technically complex, and the fact that the nature of it is quite hierarchical. At the top level, we have distributed ledger technology, DLT, that could empower the development of a number of protocols and application, and on top of which you can build specific use cases, all leading to this very exciting field of decentralized finance that to us is indeed a game changer, opening up financial services to many people who are outside of that world at the moment, but also solving some of the existing problems we have and be able to provide cost-effective solutions. Now, within this ecosystem, there are a required series of laws and regulation that would affect all the constituents you see on the screen. And the intertwining of all of them, and it's been quite complex. So we have like to demystify them all within our research. Now, a challenge that exists at the moment is truly to coming up with standard definitions, which Leon will talk about shortly, and also understanding that not all policymakers or regulators can understand all the nuances or appreciate all the nuances that exist, and the fact that Bitcoin and blockchain are not the same, certainly, and also understanding the risks that for which we need to create protective measures. And many of the issues related to taxations and token launches and so on and so forth that are in today's interconnected economy are quite important. So with that, I'll pass it on to Leon to tell you more about what we've been up to. Leon?
Thank you so much, Professor Farrukhnia, and it's been a pleasure working with you. As we've said, blockchain technology and its applications open up a number of regulatory areas of interest, from use of the technology itself by regulators as a RegTech solution for their own supervisory purposes, but also significantly through the multitude of regulatory and legal domains the commercial innovations, products, and new actors touch on. The list, of course, is extensive. One example, recent emergence of what's called yield farming as part of the DeFi ecosystem, which now touches on laws around credit, anti-money laundering, securities, and contract, amongst others. These associations between commercial activity and the potential corresponding legal and regulatory aspects can be quite complex, of course, especially if there are no obvious regulations or frameworks to apply, so that any impact is left up to legal interpretation. To visualize these associations, we've adapted the hierarchy diagram to visualize our interpretation of how the technology and usage components match up to their corresponding legal and regulatory domains. Our written report will have a full ventilation of these associations. We do see the green shoots of regulatory approaches around the world. In terms of dedicated blockchain laws or variations of electronic commerce laws where they do exist. Some of these focus on legal recognition of property rights, data on blockchain being recognized as being functionally equivalent to that of notarized information by that of a physical lawyer. A major challenge we've come across in our research is that there are non-standard definitions in many laws and regulations that do exist around the world. These can lead to regulatory confusion, arbitrage, as innovators can simply adapt the technologies to circumvent a law or may even inadvertently breach it because of the inconsistent definitions. The best approach, we believe, is to future-proof laws and regulations by using technologically neutral terms as well as principles-based regulation. We've also come across instances, especially in court cases, where the judges have had to create precedent and undertake some very creative legal reasoning simply because they don't have a set of template laws or regulations or definitions to rely on. These cases we've seen revolve around data privacy, smart contracts, and the loss of customer value because of bad coding or through hacking. We see the juggling instances the same as the early days of the internet, where there were very few laws and regulations. Looking though at approaches globally, we've found that the responses to the technologies range from clampdowns, especially on the crypto asset side of things, to, on the other side, light touch approaches. Of course, systemic approaches from, for example, the Financial Action Task Force and other supranational bodies on anti-money laundering rules, and it just released, in fact, just a day or two ago, new guidelines, identification, and profiling of crypto users, which some exchanges we believe will find difficult to implement. There are a number of innovative crypto frameworks out there, though. I just want to highlight sort of a countervailing set of parameters in Malta. Great framework, although any regulatory accommodations for new providers have been effectively reversed by commercial banks who've refused to open up accounts for these new service providers because of AML and de-risking concern. The EU has a draft markets in crypto assets framework, but we'll have to wait and see what emerges from the consultation. Thank you, and now back to you, Robert.
Thank you, Leon. So in short, our objective is to provide you with a framework and understanding the regulatory models used not only in the US, but also the realities across the globe, looking and appreciating the technology, and importantly, coming up with solutions that are actually implementable in short order without having to either reinvent the wheel or trying to force feed an existing regulation onto this new thing that's blockchain. So with that, we thank you for your time and attention, and we look forward to your questions. Thank you so much.
Hello, I'm Merritt Fox from the Columbia Law School, and I'm going to talk about my IBM project with Lawrence Gloston from the Business School concerning DLT's impact on the securities market and its regulation. So our project has 4 components. We had an initiating roundtable where we brought a broad group of different people, technical, market, legal, together to help conceptualize the project back in June of 2019. A stakeholder survey where our interest is in finding out views about DLT and the securities markets from a range of different kinds of participants in the market. We have completed a preliminary white paper based on the ideas that have come out of the stakeholder survey so far, which is about halfway through. We've interviewed about 50 out of our potential 100 people. And then finally, there's going to be a conference on the future of securities law with a final white paper. And the motivation for this project is we recognize that DLT is an integral part of what's really a larger revolution that's been going on for several decades in computing, communication, and data storage, and that's really transformed our securities markets in recent decades and promises further radical change in the years to come. And we felt that it was important to see how the people on the ground, the stakeholders, are seeing these developments and what they see coming down the pike. Try and give you a sample of the kinds of things we talked about. One topic of discussion is simply moving the entire process of trading stocks onto a DLT platform. So let me just kind of elaborate on that. And we're going to hit 4 points. First, how the system works now, how it might work on DLT, the advantages of making the move, the technical and institutional problems that are impeding this move, and finally, some potential first steps. So first, how does the system work right now? Well, first we have a trade. We have some kind of trading venue that gathers trading, buying and selling interest and matches sellers and buyers. And that trade that occurs on the venue or exchange is essentially an anonymous promise from the buyer to the seller and the seller to the buyer that each will subsequently exchange a given number of shares for a given price. Then next step is this is just mutual promises. 2 days later, the promised money is exchanged for the promised stock. And then after that, the issuer's stock ledger has to register the change in ownership so dividends can be sent to the new owner and the person entitled to vote the shares is established. Now, a critical feature of the current system and for any stock trading system is that buyers and sellers feel confident that their deals will be honored. That's critical for an anonymous market to function. Just think about it. Most of the time, 2 days later, one side or the other will regret having entered into the transaction. If prices are higher, the seller wishes he or she had waited. If they're lower, the buyer does. So currently, this confidence is established by a complex system. It requires every buyer or seller to place its order through a broker. The broker acts as a backup should its customer fail to perform, and clearing and settlement includes a system whereby other brokers, in essence, back up a customer's particular broker in case that broker fails. What would be involved in fully moving to DLT? Well, a DLT system could involve really all three of these functions. In terms of the trading venue, you'd still need a venue to take in interests of each side and match, but it could record the match of buyers and sellers. Then clearing and settlement could occur instantaneous, an exchange of stock for digital consideration. And then the transfer agent and stock ledger function could occur because registration of the new owner could instantaneously occur on the issuer's books. And that has a number of advantages. First of all, brokers and the clearing and settlement entities, these are now institutions that consume considerable resources, involve considerable costs, would no longer be necessary to create that, to make the system function, avoiding their associated costs of operation. Also, making the exchange of stock and consideration instantaneous would free up capital currently required to back this 2-day lag. And the DLT system could also manage each corporation's stock ledger more efficiently, and that both simplifies sending out dividends, doesn't have to be done indirectly through nominees, and it avoids chaotic close share votes involving important transactions such as merger proxy fights over mergers and so on. Now, there are a number of impediments, both technical and institutional, to this kind of full transformation. First, one is scalability, particularly for the largest 500 or 1,000 companies. So think about it this way. Currently, Bitcoin can handle 4 transactions per second, but over 1,500 transactions occur per second on US stock exchanges. Also, the payment system. If we really want to eliminate all trusted intermediaries, digital coins rather than dollars would need to be used, but digital coins have a number of disadvantages. High volatility in value, we're all familiar with that, and the insecurity of digital wallets. There have been numerous thefts. But there are also some institutional impediments. Obviously, to start with, there are vested interests in the existing way of doing things. People make money doing this, that they won't be able to make money anymore. So they're going to resist politically. Very important, the SEC relies on brokers to monitor illegal buyer and seller activities such as manipulation. Unless some kind of substitute form of monitoring could be developed, eliminating brokers would be a non-starter from a regulatory point of view. Then also the need for coordinating many actors to join in an effort that only delivers much of its benefits. If all of an issuer's stock trades on a DLT platform, would require a significant, probably government action. At the end of the day, I think probably the good is the enemy of the great here. Even if this really could work better, the current system works well and by historical standards at quite a low price. So that there's not really the impetus to get over some of these problems at the moment. Now, here's some potential first steps, though, that might get around these problems. One would be confine the reform only to sort of a record-keeping part of clearing and settlement, but not integrated in with the market. And the other would be start by doing this more full DLT-based system just for smaller, more lightly traded issuers. So thank you so much.
Hi, I'm Steve Belvin. With me here today is student Andres Perez. Together, we've been working on a different approach to privacy. Traditionally, privacy has been governed by notice and consent. This is a 50-year-old paradigm. It no longer works. There are too many parties, many of them, such as advertisers who are invisible, collecting data on people. Privacy policies are vague and overbroad. Often it appears deliberately so. Data sets from different sources are often merged, creating a much greater threat to privacy than any one data set. And today's powerful machine learning algorithms permit damaging inferences to be drawn, even if no one data item is itself sensitive. Instead of trying to limit collection, we propose use control. People could decide what their data is used for rather than how it's collected. So we've implemented a web browser extension where users can select what kinds of uses they will permit, perhaps more relevant content, targeted advertising, some people prefer relevant ads, medical research, and so on. And the user's preferences will be written to the blockchain. Why the blockchain? No single entity controls it. This is the World Wide Web. Billions of users around the world, many, many companies collecting data. So we don't want any one party controlling it. It's immutable. Records are permanent, so no companies can tamper with it if they need to defend themselves. Anybody, any user of the internet can write to the blockchain. Anybody can read from it. Any advertiser, any website, any would-be data user can read from it and see what kinds of uses individuals will permit. I'm going to now turn it over to Andres, who's going to discuss the implementation.
Thank you, Professor. So for the implementation, we decided to develop a Firefox extension where the user can manage their privacy settings for browsing, right? We also display each category as a separate item. So if an advertiser wants to use it for more relevant ads or the website wants to use it for more relevant material, those are categories that will appear in the pop-up. And then under each category, you'll be able to find more information about how their data is going to be used. Now, the users can specify their preference for each category and then hit the save button to save their preferences to the blockchain. And what's innovative about this approach is that previously saved preferences for other websites will be overridden by the latest set of preferences that the user sets. Now, the technical aspect of the extension is that when the user hits the save button, the extension generates a JSON object composed of the URL of the website and the wanted privacy settings for the website. After the extension generates that JSON object, that is sent through a Node.js app that's in charge of writing the record to the blockchain. So you might be asking how the record will be made authentic, right? So each object will be signed with a hash concatenation of a unique ID, a public RSA key, and a domain name. Also, the helper app will keep a list of the website along with the keeper and the unique ID, as well as a global unique ID in local storage. We decided to run our app on the IBM blockchain platform. We developed a smart contract that runs on the platform that allows users to write their preferences to the blockchain. Why is this good? Because each record is immutable, and then users can easily check at their latest set of preferences, just in case they want to change them and they want to compare like what they had before and what they're gonna have after. And it also provides an easy way for websites to retrieve the user preferences for the blockchain. Each website can run a script that will retrieve the latest set of preferences for each user. So how can this scheme and this solution actually protect privacy effectively? By making the blockchain public and accessible, it's easier for government agencies such as the Federal Trade Commission to hold websites accountable. So, you know, it would be really easy because the agency would just check at the latest set of preferences and then compare it to how the data is being used by the website. Also, these records are easy to verify thanks to a digital signature, and we can compare each user's public key in local storage to a public key in the record to verify its truthfulness. And also, it preserves the anonymity of the user by providing each website with a separate key and a unique ID for each website. That way, the user cannot be tracked by the merge of data sets. So the implementation is almost complete, and now we're working on a paper that will include a more detailed explanation about the technical aspects of it. And now I'm gonna close for questions. I'd happy to entertain any questions.
Good morning. I'm going to be talking to you about neurotechnology, and specifically about the role that neurotechnology will have in the future of humanity, and how we should be concerned about it, and we should make sure that we set out a path which is ethical and consistent with societal values. So all of this starts in 2013 when President Obama launches the US Brain Initiative. This is a large-scale scientific project that involves more than 500 labs around the country and the world today. It's supposed to last 15 years, estimated budget of $6 billion. And the purpose of this is to develop neurotechnology. What is neurotechnology? New methods, new tools to perform three goals. One is to measure the activity of every neuron in the brain. The second is to be able to activate and manipulate the activity of every neuron in the brain. And the third goal is to computationally analyze this data with novel software and mathematical tools. Taking after the Human Genome Project, its older brother, the US Brain Initiative is progressing by building these tools to analyze in their completeness the nervous system of small animals, that would be like worms and invertebrates, and then graduating through flies, fishes, eventually getting to mammals like mouse and the human brain. So the US Brain Initiative is not alone. In fact, the Brain Initiative has spurred the creation of similar brain initiatives throughout the world. So we now have brain initiatives in China, in Japan, in Korea, Australia, Canada, Israel, and the European Union. So we're actually, since last year, we've formed a global brain initiative, the International Brain Initiative. So we're talking about a revolution in the tool building for neuroscience. And this is going to be fantastic. There are three main benefits. One is for science. With this tool, we'll be able to finally understand how the world works. And the brain, as you know, builds our minds. So by understanding how the brain works, we'll understand ourselves for the first time from the inside scientifically. The second reason why this is important has to do with the clinic. As you know from personal experience with family members or friends, neurological and mental diseases have no cure. And the reason for that is because we don't understand how the brain works. So it's just like a car. You need to figure out how it works and be able to fix it. The third reason has to do with the economy. So neurotechnology, just like the Human Genome Project before it, could launch the opening of a new type of enterprise, neurotechnology, neurotech that could revolutionize computer technology and the tech industry. This is all wonderful, but let me remind you that the brain generates the mind. So if we're able to go in with our tools and read the activity of brain circuits and manipulate or modulate the activity of brain circuits, we're actually reading mental processes and manipulating mental processes. So we have to be very concerned about how these tools, which are very necessary for the future of humanity, how they get applied to the population. And because of that, a group of us, 25 people that I represent, coming from neurotechnology, representing all the brain initiatives from throughout the world, representing the tech industry, neurotechnology industry, the clinic, biothesis. We hold ourselves together here in this building at Columbia University, and we proposed in 2017 4 ethical priorities for neurotechnology and AI. We think that we're dealing with a problem that has to do, impacts the human rights. And we coined the term neural rights as new human rights that you can imagine be cerebral rights that we think should be added to the Universal Declaration of Human Rights, which is written in the wall of this museum in Chile, Museo La Memoria in Santiago. So the new human rights will be the right to mental privacy, the right to our own identity, to ourselves, the right to our own free will, our agency, the right to have equal access to cognitive and mental augmentation, and finally, the protection from bias and discrimination. So to pursue this agenda, we've created a group of people here at Columbia, the Neural Rights Initiative, and for the last couple of years, we're involved in pushing this agenda in 3 different directions. The first direction is a protective direction, a defensive path, and this is to implement legislative protection for neural rights. We're working with different countries, with Chile, with Spain, with the European Commission, with Kenya, and in Chile, we're very far. We are in the process of putting in a constitutional amendment to the Chilean constitution. Here's supported by the president, the minister of science, and the leader of the Senate, and also a new bill before the Senate, the Neural Rights Bill, that would establish for the first time legally concepts such as neurotechnology, brain-computer interfaces, neural rights, defines neural data as a body organ, and proposes a medical model for the use of non-invasive brain-computer interfaces. It's a defensive maneuver. We're also more proactive, and we have the proposal of a technocratic oath for the tech industry. The idea is something very similar to what happens in medicine, where every medical doctor, including myself, when we graduated, we took a personal oath, a Hippocratic oath, of using our knowledge for the benefit of mankind, of humankind. We think the tech industry is ready for this, and we're proposing a tech oath based on 4 principles: the principle of beneficence, do good; principle of justice, treat everyone equally; principle of dignity, respect human dignity; and then principle of transparency. This technocratic oath has been pioneered in Spain, the Basque Country, and also in Chile. And this is one colleague of mine who has an AI company, Uribe Echevarria, in the Basque Country and in Silicon Valley, who's adopting this technocratic oath. And finally, a third approach, strictly a technical approach. So this is just working with engineers and with experts, in this case with George Ripsack from our medical bioinformatics unit at Columbia. And the idea is to come up with algorithms that prevent these problems by treating neural data taken by neurotechnology, in ways in which we don't need to worry about issues like privacy, because that data would not be shared. So this is a case of using federated learning, for example, where the data doesn't leave the device, or when data is shared, that is shared according to a data-sensitive hierarchy, where every different type of data gets a label that determines how sensitive it is in terms of privacy. So we're exploring concepts like data sensitivity hierarchy and privacy, data differential privacy. And I finish also with an invitation to all of you to join us on November 19th on an online symposium on brain-computer interfaces, which are the heart of this neurotechnology. The brain-computer interfaces are the devices that connect the human brain to the net, And this is a symposium that's sponsored both by the DSI at Columbia and IBM. And we've lined up world experts on this technology, and we're going to be looking at both the technical hardware development of this technology, the data, software treatment of this data, and also issues that have to do with the ethics and societal applications. Thanks a lot.
Today, we present the news authentication project in which we are creating a technological system for news publishers to cryptographically secure the provenance of their content. And a quick note, we use the term authentication in our title to denote originality of the content whose source is known, and not to determine the truth value of the content. So that's a specific use case for authentication. And before we delve into the project's technological and design details, we wanted to give an overview of who we are, what the industry level problem is that we wish to tackle, and also discuss the broader environment into which this project fits. So first of all, we are a team of faculty and students at Clemson University, New York University, and Columbia University with research and professional expertise in computer science, human-computer interaction, cryptography, journalism, and communications. And the problem at hand that we are identifying here is that we see a diminishing trust, readers diminishing trust in the information and the news that circulate online. And a number of broad factors play into this phenomenon. First of all, we see the gatekeeper role of legacy news publishers waning in recent decades. Markers of professional journalism that would allow end users to quickly and easily distinguish between personal stories, partisan opinion, or professional news reporting. This often gets lost on digital platforms. And as a result, the fact that users end up seeing conflicting information or biased coverage or just personal stories can lead to a loss of trust in professional journalism, or to an apathy toward following the daily news cycle, for instance. Now, there have been a number of blockchain solutions in the media space. Just to quickly summarize, we can group them into two buckets, two main approaches. In one case, which usually involves private blockchain networks or IPFS directories, content creators can securely store metadata such as bylines or timestamps in a decentralized database. And this can be done to secure intellectual property rights, or to communicate the provenance of content to readers and to end users for the sake of transparency and accountability. And then the other bucket is in which blockchain-based cryptocurrency tokens are used to improve a variety of services, such as ranking trusted advertisers in a registry, or incentivize user engagement through micropayments, or fund content producers themselves via cryptocurrency tokens. So with the news authentication project, we are aware that this is an increasingly crowded space of competing solutions. And that is why we need to specifically define our own goals and identify our users. And with that, I'd like to hand it over to my colleague, Errol.
Thanks, Bernat. So what makes our project different from what's currently being done, or what's already been done? And what do we hope to gain from our research? Well, actually, there are some distinct differences in how we approach digital media security that separate us from pre-existing projects. So first, let's talk about our goal. As Bernat mentioned, there's an inherent trust problem around how news consumers think of news production. With this in mind, our primary goal is to create a news system that cryptographically authenticates digital media and effectively communicates this information to readers. Through the creation of this new system, we can explore the effect cryptography plays in ensuring the transparency and accountability of digital publications. We can also evaluate the impact that the provided authentication information has on a user's perceived trustworthiness of news content. So if a publisher includes a digital certificate or a signature authenticating their news, does that give a user greater reason to trust what they're reading? Finally, with our system in place, we can investigate if accountability and transparency of the system has an impact on users' consumption and or confidence in the publishers themselves. So will a user choose to visit the page of a digital publisher who includes some form of authentication more than the page of a digital publisher who doesn't? Now, we talked about our ultimate goals. Let's talk about goals that make us different from what's already being done. So first, our system is not trying to assess if a news item is true or fake. So we're not trying to detect fake news. Our system will not take any steps to address disinformation or misinformation, so it will also remain pretty neutral in terms of potential censorship. Second, while our system may seem to have a plagiarism detection angle, it actually has no strict built for preventing plagiarism. With our system, it might be easier for industry partners to gather evidence of plagiarism if a publisher chooses to do so, but it's not specifically the case that that's what it's built for. Finally, the system will not attempt to enforce any type of content restrictions such as paywalls or having people subscribe to get certain content. With that being said, we will use a cryptographic approach to privately log data in order to support both freely available and rights managed content. So in this presentation so far, you've heard me use terms such as users, readers, publishers, but who are these people? Well, for us, they're the three potential subgroups of users that could benefit from the news authentication and the strengthening of digital media. For readers, that's the general public. Publishers are journal institutions, and industry experts or industry peers are experts such as lawyers, watchdogs, archivists who could use this content. For the purposes of the presentation, though, we'll only talk about the first two. So the readers are what we consider the general public. They consume digital media on a daily basis. One of the biggest challenges that we face in digital media security is understanding how users comprehend and interact with content provided to them that attests to the authenticity of information. We also have to consider what interfaces we can implement to encourage users to use authenticity information when they assess the credibility of digital media. And finally, the publishers. For our research, it's important to investigate how experts in journalism, such as journalists and publishers, use this authenticity technology. So will it affect their behavior and general approach to producing content? Will it make them more diligent when they are initially publishing content and when they go and update content online? And how will this authentication be integrated into their workflow? To talk more about security, I'm going to hand it off to my colleague, Billy.
Thank you, Errol. Another significant portion of our project is mapping some of those authentication and transparency goals that were just discussed onto systems that are going to be implemented. Here you can see a rough outline of the potential architecture. And we just want to note that this was strongly influenced by previous projects in various domains, but most notably certificate transparency, which demonstrated the successful adoption of verifiable logs at scale. One of our key design goals throughout this effort is that we want to minimize the amount of effort required from publishers who'd like to participate in this system. If I may call your attention to the top left of the diagram, we can see that this depicts a publisher's existing architecture. This will, of course, vary greatly in sophistication, but as you can see in this example, there's potentially only one additional API call required to push metadata to the transparency log, allowing the publisher to participate. We're still exploring the best approach for the transparency log implementation itself, considering projects such as Trillion, which was at the core of certificate transparency, public blockchains like Ethereum, and permission blockchains such as Hyperledger Fabric. The log will be publicly accessible for read purposes, but it will be restricted for write purposes to avoid, spamming it with useless information. The web browsers of the readers are depicted sort of in the center of the diagram with the installed extensions, which will be developed based on the findings from the user experience research that is taking place as part of this project. The one entity that's not depicted here are the third-party monitors and auditors that we expect to primarily interact with the transparency log. And finally, we kind of want to touch on some of the challenges that we've been facing throughout the project. And the first one is just kind of a general point about the scope. There's just such a broad range of potential issues as soon as you start talking about authentication, transparency, trust in the news, affecting the entire supply chain. So while that speaks to the need for work in this space, it can sometimes be a challenge when there's not just one obvious bottleneck to focus on. In addition, the dynamism of everything and the interplay between the user experience research, the software requirements, the technologies available, and underlying all of that is sort of an evolving industry. So, but that does keep everything interesting. So we appreciate it. Adoption is a key point. That's a challenge for a lot of two-sided platforms. If we have a bunch of users who install the extension, but no publishers are participating, then they're not really getting much value out of that. And incentivizing publishers to participate can be a challenge if we're not able to demonstrate that there will be a significant user base deriving value from their participation. And then finally, just a pragmatic challenge about the canonicalization of, how we're mapping, various potentially legitimate differing versions of the same article to one article entity has been kind of a technical challenge that we're working through, and it can often be in tension with the design goal of minimizing our footprint on the publisher infrastructure. So that's the majority of the material. We, of course, want to acknowledge the support of the National Science Foundation. Thank you.
Hi, my name is Gur Huberman. I've been teaching at Columbia Business School for over 30 years now in the finance group. I used to teach capital markets and behavioral finance, and now I'm into this fintech and Bitcoin, cryptocurrencies, and blockchain. I'm about to describe to you the course that I'm teaching this semester with Omid Malakan, who is an adjunct professor, and then his day job is advising to Citibank on blockchain and other payment issues. In the course, the prototypical student I have in mind is one who will go out and become a product manager. In my mind, the product manager is one who intermediates between the engineers, the designers, and the customers of the marketplace. So we're not going to make our MBA students into engineers. Some of them have been trained as engineers, that's fine. But the course is intended not only for engineers, but for other people as well, with the idea that they will be able to establish dialogue with the engineer, explain what the market needs are in their eyes, and understand from the engineers what it is that can and what it is that cannot be done. So what are the topics in the course? We start with the question of what is money? And that may seem to some people as a trivial question. To others, it's a very profound question, because when you start thinking about this, it's really not clear what money is, given the way its various incarnations over the years and the current uncertainty over what money and what the payment system is about. So we'll talk about that, and then another class, would be about computer science topics that are relevant to blockchain and Bitcoin systems. We're going to have as guest speakers, we have already had in the first class, the two gentlemen who actually invented blockchain, namely Stu Haber and Scott Stornetta, who in 1990 wrote a paper about how to timestamp digital files. And that was a pioneering work that really established the notion of a proto-blockchain without calling it that. In Satoshi Nakamoto's celebrated paper, he cites three of the papers that talk exactly about timestamping digital records. So we're going to talk about that. We're going to talk about hash functions. We're going to talk about private public key cryptography. And most importantly, we're going to talk about the idea of consensus, which again, may seem trivial, but to those who study this in computer science, they realize it's really far from trivial. And to MBA students, it is striking, the idea that it's not trivial to put together a consensus of what the state of the world is. In fact, I begin by assigning them a task, picking on one student, asking him to use only email and organize a meeting for the following week of 30 students in the class. So that's the second meeting, more or less. The third meeting, we talk about Bitcoin itself, how it is organized, how the blockchain of Bitcoin is organized, with miners, with use of send transactions. This is to a large extent based on some insights that about which I wrote in a paper called The Economics of Bitcoin Payments. And then we move on to another topic, which is the one major topic that developed after Satoshi's paper, which is smart contracts, which are which were pioneered by Ethereum. And that's more or less the first half of the course. The first half also deals with how you actually work with the blockchain, and what are the possible glitches, what are the possible attacks. That's about the first half. The second half starts with, again, with the smart contracts and uses them to establish the idea of a stable coin. So we go over a stable coin. The one example we use is Tether, which is sort of a miracle. With all the bad name it has, it trades at par, which is quite interesting and quite, to me, a puzzle, given what we know from economic theory about bank runs. So I actually used the opportunity to teach them about bank runs and pose the question of why Tether has not been run. And frankly, I don't have an answer. Then subsequently, we talk about central bank digital currency, which now is a very fashionable topic. In fact, it will be widely discussed in October in a meeting of the G7 and a meeting of the G20, which are annual meetings organized by the IMF. And we're going to have a guest speaker from the IMF who is going to write the position papers of the IMF on the topic. So I'm not quite sure what the IMF will have to say, but certainly the students and I are looking forward to that. Past that, we'll talk about non-money-like applications of blockchain, such as supply chain, and we'll have guest speakers who will cover that. Finally, to impress you that this is an important topic, we look at the data and look at the importance of payment systems. For instance, in the past couple of years, per year, the revenue of payment companies that support the payment systems was like $2 or $3 trillion. Now that's a huge amount, and people are paying that because the payment system works, but doesn't work very, very well. So that's roughly a broad bird's eye view of the course, and I'll be happy to take questions if you have any.
Hello everyone, I'm Jerry, the senior at Columbia Seas and co-founder of TensorPlace, a transparent marketplace and talent platform for machine learning capabilities. In fulfilling this mission of building the first transparent developer marketplace for machine learning pipelines and code bases, and a talent platform for small and medium-sized enterprises, I fundamentally believe our team is one of our core strengths. As machine learning enthusiasts ourselves, we deeply do understand this space. I'm Jaydev, CEO and head of product, Nikhil Shah, CTO and head of strategy, and we have a very strong engineering team comprising of Yash Sasani, our software engineering lead, and Pinang Doshi, our product manager. We're also very fortunate to have strong advisors, including Nikhil Patel, former CEO of LendingTree, America's largest lending marketplace, angel investor Professor Billers, and blockchain entrepreneur and serial innovator Professor Chong Li. So what is TensorPlace? TensorPlace is a marketplace for affordable specialized machine learning pipelines. And it also serves as a developer talent platform for small and medium enterprises. On TensorPlace, we guarantee consumers access to well-documented, hard-to-find deployable pipelines or APIs, along with the ability to ask for the original developer's help or customizations. We also leverage IBM's Hyperledger Fabric blockchain to provide comprehensive verifiable reputation metrics. And we match enterprises to developers with similar pre-built solutions, dramatically reducing cost, time for search, and time to deployment. So let's now take a look at our core differentiators. Verifiable reputation. This is incredibly important because this means a developer can use his or her TensorPlace reputation score on his resume or post in our online community to verifiably prove his work's credibility to employers or customers. But even more importantly, it greatly increases marketplace transparency when a consumer is looking to buy a digital product. Another feature in the process is machine learning development lifecycle services. And a good example of this, for example, is domain expert matching for specific machine learning use cases. And even further down the line, stuff like edge deployment, which is a big need for computer vision startups. Machine learning development is a market that's growing exponentially. In 2019, this market was sized at 39 billion, but it's projected to go up to 100 billion by 2023 and growing even faster. The number of software engineers entering this space is incredibly large. There's a large influx of even non-engineers looking to enter machine learning engineering because it really is transforming how businesses run their processes today. And this goes to show that software ate the world once upon a time, but now AI is eating software. And TensorFlow wants to be at the forefront of that transition. This is basically a slide of developer affiliations of people who are registered on TensorFlow's waitlist. We have 300 plus software developers from a large spectrum of companies ranging from academic institutions like Columbia, Berkeley, and MIT, but also established companies and companies which are not traditionally in the tech industry, like insurance companies. And yeah, this really does go to show that TensorFlow fulfills the need for developers across the spectrum looking to get into machine learning engineering. So I do want to talk a little bit about our journey through the Columbia-IBM blockchain accelerator. We came in with an MVP based on Ethereum and Solidity. This is primarily a class project for a class I took with a few of my peers last fall. But realizing the promise of that project, we applied to the IBM accelerator in the hope that we could leverage the resources it provided us to make the jump to the next level. And this really did pan out to be true. From a technical standpoint, one of the biggest helps we got was the help in making the transition to Hyperledger Fabric, for which we got concrete technical feedback, including pros and cons of the service from our IBM mentors, Mark Trishak and Jia Chen. But more so from the business standpoint, these accelerator sessions really helped us inspect and strengthen our business model. Our favorite sessions were those that taught us how to tell the company story and pitch our vision. And we also had many helpful calls with other accelerator mentors for business help, targeting our market, coming up with a good go-to-market strategy, and so on. We also put the IBM Cloud Credit to great use, not only for hosting our website, our portal, and also running the Hyperledger nodes, but also for training our own models that we want to put on TensorFlow as our first set of products. And lastly, the demo day and the demo day preparation sessions were really good for getting valuable feedback on our product as well as our pitch. And that's it, folks. Thank you for listening to my presentation. If you have any questions, feel free to contact me at jaridev.chat@columbia.edu. And we're looking for partners. Thank you so much.